Hello students, welcome to my channel Study with Alakesh. In this class, we will try to solve some very basic numericals in which we have to find out what is stress. Alright, so let's go with the first example. This is a bar of square cross section. Square cross section means length and breadth are same. Alright, and the load is applied 40 kilonewton on the both side, which is tensile in nature. Alright, now in this case, if we have to find out the stress, then how should we proceed? Alright, so before going with the numerical, I would like to point out a very important part in case of strength of material while solving the numericals is, although the SI unit of stress is Newton per meter square, alright, but we will try to solve or keep the units in Newton per mm square. Alright, see, the main reason is normally we are considering the metallic rod or metallic bar. Okay, so in that case, even if you are applying load, sometimes the change of length or change of diameter is so small that we can't even see through our naked eye. For easy calculation purpose, we would like to keep the units in Newton per mm square. Alright, okay, let's start. So obviously it is tensile force, so the stress developed will be tensile in nature. So what is the load? It is 40 kilonewton, which you can say as 40 into, since it is kilonewton, it is 10 to the power 3 Newton, right? Okay, then what is the area of cross section? Area of cross section, since it is a square, then it should be 20 into 20 or 20 square or L square, what you can say is. So it is basically 20 mm square, so it is 400 mm square. Are you getting my point? So you have P and you have A. Okay, so what is stress? 40 into 10 to the power 3 by 400. Okay, now we can say 400 as, suppose this is like 4 into 10 to the power 4. Okay, 4 into 10 to the power 4, and in below it is 4 into 10 to the power 2. Correct? So 10 to the power 2, 10 to the power 4, it will be like 10 to the power 2 here, and 4 will get out, get cancelled. So it will be like only 10 to the power 2 Newton per mm square, which is nothing but 100 Newton per mm square. Alright, 100 Newton per mm square. Alright, and if we convert this into Pascal, it would be like 100 megapascal. 100 megapascal. Alright, that means suppose 1 Newton per mm square, 1 Newton per mm square, if we have to convert it into SI unit, then what is mm? mm means 1 mm means 10 to the power minus 3 meter, correct? So 10 to the power minus 3 meter square. Okay, all right. So it will be what? The Newton by 10 to the power minus 6 meter square. Okay, 10 to the power minus 6 meter square. Now if it is 10 to the power minus 6 in below, then what will happen? If it goes up, 10 to the power 6 Newton per meter square. 10 to the power 6 means what? Mega. So it is 1 megapascal. Are you getting my point? So 1 Newton per mm square equals to 1 Newton per mm square equals to 1 megapascal. It is a very important conversion for strength of material numerical purpose. Now let's come to the next example, next type of example, where we have a shaft or bar of length 10 centimeter, but the only difference is the cross section is here, it is a circular. Okay, it is a circular kind of bar or shaft. Okay, now if we have to find out only stress, then the length is of no use. All right, provided on F and area is given. Here, if we have to find the stress, if we have to find the stress, okay, first write what is given. Given P equals to 300 kilonewton. That means 300 into 10 to the power 3 Newton, right? 300 into 10 to the power 3 Newton. Also, for the easy calculation part, you can consider this as 3 into 10 to the power 5 Newton. Okay, so there are two zeros, so it is 10 to the power 2 into 10 to the power 3, so 10 to the power 5 Newton. Got it? Now, what is this? It is the diameter. If this is the diameter, then what will be the area? Area of a circular part, it is nothing but pi by 4 the square. Alright, since it is in mm already, so no need to convert it. So what is pi by 4 into 15 square? 15 square. Okay, now what is stress? What is stress? Stress is nothing but load, that means 3 into 10 to the power 5 by area, pi by 4 into 15 square. Alright, so if you put the values like this, if you put a value in calculator, then obviously you will get a value almost equal to 1690 megapascal. Sometimes what will happen, if you do it without calculator, you may get suppose like 1689, 1691. This kind of approximation is fine. Okay, but if the answer is 1690 and you are getting 1500, then it is wrong. Alright, so let's get into the third case where a force is applied like this, which is 200 Newton. So from the diagram we can identify that this is a case of shear force. Alright, because the force is acting parallelly to the surface that we are considering. Okay, we are considering this surface, then this force will be parallel to this surface, so this will be shear force. Now what is the area given? Area is 10 mm square. So it's a very simple concept. So what is the shear stress? Shear stress will be, see, the unit conversion is not needed here. It is in same, okay, in Newton and in mm square. So what is shear stress? It is PS by area of cross section. So what is PS? 200 Newton by area 10 mm square. So it is nothing but 20 Newton per mm square. Okay, so Newton per mm square means in terms of megapascal it will be MPa, 20 MPa. Alright, so I hope you have understood everything, and if there is any doubt then you can ask me in comment also. Okay, and if you like this video, share among your friends and subscribe the channel for more upcoming videos. Okay, thank you, take care, goodbye.